Welcome back students and very good morning. Today we are going to discuss the continuation of fuzzy logic. So in the previous session, in the previous class, I have already explained you regarding the basics on fuzzy logic. I explained you what is a fuzzy logic, what is a fuzzy set, and also we have seen the operations on fuzzy set. So now today we are going to learn about the architecture of fuzzy logic. So basically in the architecture of fuzzy logic there are four terms are being used. The first one is fuzzifier, which is performing which process fuzzification, and the second is how there are some certain rules in that, so that rules has to be satisfied. I mean these rules are there such as if then rules will be there, and that if then rules will be taken here, and intelligence part. So this intelligence part actually is your inference engine. Like already in expert system you have seen what is an inference engine. So what is the role of inference engine? Inference engine actually takes the rules which are predefined by the already which are already predefined by the fuzzy logic. So that rules, for the particular applications, whatever the applications you are doing, based on that specific rules has been defined. So that rules has to be taken, and that rules are in the form of if then rules. So this if then rules will be taken into consideration, and with the help of inference engine it performs on the fuzzy input set, and what happens is that it gives you the output, but the output will be in fuzzy form. Okay, but in order to get the output in normal form, that is crisp form, we are using defuzzifier. So basically the role is whenever you are giving an input, so you are giving the input in crisp form. Okay, crisp form is something like the input is your the input is specific. Okay, it has some specific value, the value is very precise in nature. But what happens if I am using fuzzy logic system, if I am using fuzzy logic architecture or the concept of fuzzy logic, so by this fuzzifiers, what happens is that this crisp data will be get converted into fuzzy input set. Now how is going to convert? So that is what we are going to see here. So that's why I said you in fuzzy logic the first part is your fuzzification. So what is this fuzzification? I said you the input of the fuzzification. What is the input of fuzzification? The input of the fuzzification is the crisp data. Okay, so here this crisp data, okay, will be converted into a group of values. What it converts? It converts into group of values. Okay, so that group of values are constitutes to be a part of fuzzy set. Okay, how is going to be get converted? For example, if there are input signals are there, let us consider some signal values there, but now that signal value is actually your crisp data, the crisp information, the correct information. But what I am doing here is that I am taking certain things, such as I am dividing that input into a set of values such as large positive, medium positive, small, medium negative, large negative. Okay, previously also in the previous session I have explained you some examples here, like some kind of fuzzy sets. What happens? The data is not at all clear. There is a value called 0 to 0.25, 0.25 to 50, fast, fastest. So what is this slowest, slow, fast to fastest is actually here is their fuzzy set. So this fuzzy set, how you will going to operate, how you will going to get with the help of fuzzifier. Fuzzifier used to perform the process called fuzzification. That means that has been divided, but here we taken some other example, something like LP represents for large positive, MP represents for medium positive. That means if the number is too large, then you can take in large positive fuzzy set. And if the number is not that much bigger number, but it is in positive way, so you can take in medium positive. And if the number is small, simply I can use small. but if the number goes negative in 1 but not that much, then you can go for medium negative, and if the number is too negative, then you can go with large negative. This is just for an example for signal. So in any of the example, we have to divide by our own, that is, it's up to us that how we are dividing the given things into a group of values, a group of states. Okay, what is this group of states? So that's the process is your fuzzification. So in this fuzzification, that is the first process. So after getting that fuzzy input set, so as we got that input set, right, so that input set will give you, will take as an output, and it will give as an input for intelligence. That means it will use the inference engine will take that values. Okay, what is, as I said you just now, intelligence is how the inference engine, it infers the value, it takes the value and it infers based on the given rules. Anyhow, I will take you an example and I will show you that how these rules are being adopted or implemented in order to get the output of this one. Okay, so that is, you will get a clarity once we will take an example with this. So right now what you can think is that intelligence house is the second process. I mean, like what happens here, that is inference engine. Just now I said you, right, so in inference engine what happens, it whatever the input, I mean fuzzy set input you are getting from fuzzifier, and also it takes the rules. Okay, these are fuzzy rules. So here these are the rules, what you can simply call them as fuzzy rules. Okay, so based on this fuzzy rules and based on the input, so inference engine will take two inputs, the one is the fuzzy rules and the second is the fuzzy input sets. So based on these two inputs, it acts on that and it gives you an output which is still in fuzzy set only, but that is your fuzzy output set. So now what is the rules actually? The rules are, I mean rule based, you can call them as fuzzy rules. So it contains actually, these rules are in the form of if then condition. Just now I said you, right, if that means there are some set of conditions are there, so that conditions, based on that conditions, what happens, you need to frame the rules. Okay, so the rules are being framed in the clause of if then conditions. Just now, just the same thing as we have seen in the expert system, in the same way it is. Okay, but the thing is that these rules are being used with the help of fuzzy sets. Okay, previously we haven't heard about fuzzy set or fuzzy set input. Okay, but now this rule base are being used along with the fuzzy set. That's the difference here. So here what is the role of this one? So this if then will be used to control the decision making system. That means how to decide, what to decide, what should be an output, what should be an action. So all the set of actions will be decided by this one. So this rules and the input, fuzzy input, will act as an input for inference engine. So that is why what happens, it matches. Now what is the role of inference engine? It takes the input from fuzzy set, so this is fuzzy input and the rule, so it matches. I mean for the given fuzzy input, which rule is to be matched. So the matching performs, and based on the match what happens, it determines that which rule has to be implemented according to the given input. Okay, which rule has to be implemented according to the given rule. So for example, if I say like here, I mean like if I say consider washing machine, in washing machine also what happens, it uses fuzzy set technology. Okay, based on the input, that means if you have given a cloth, a dirty cloth, a more dirty cloth, what happens, an action. Okay, that means the time period get increases, because you know that input what we have received, the input is of quality that it requires more time. How it will perform based on the input. So who will decide? This inference engine will decide that what kind of action has to be performed. So based on that, particular rules has to be combined. So that rules has to be implemented to develop the control action. So the actions can be like you are giving more time or less time for washing the clothes, and all like that. If I consider a washing machine as an example, not only washing machine, most of the machines right now currently they are using the concept of fuzzy technology. So this is how the inference engine, in the same way, what happens at the end of fuzzy inference engine, I mean at the end of this intelligence, what happens, it gives you as fuzzy output set. Now this output is also in fuzzy, but what we want a specific time for how much time that machine should work. Okay, for particular cloth, how much time that machine particular for that particular, so an approximate time will be allocated with the help of whom? Defuzzifier. So it requires crisp output, means exact output it requires. Okay, the output should be very much clear. Okay, because of that only the machine works in that sense. So this defuzzifier, who will do this process? What is the role of defuzzifier is, the defuzzifier takes that fuzzy output sets and it converts into crisp output. That means it targets and gives you an exact value. So that is the role of defuzzifier. Simply that only I said you, right? So it takes fuzzy set as an input and it gives you as a crisp value. So there are many techniques are being available, so that based on that particular technique which best suited for the given expert system, that has to be decided. Okay, so in that sense defuzzification process will come performed by defuzzifier. Okay, so these are the four major components for fuzzy logic. The first thing is that fuzzifier, I mean which will do fuzzification, it takes the crisp input, converts into fuzzy input, and based on the fuzzy rules and based on the fuzzy input set, inference engine will give you fuzzy output set which acts as an input for defuzzifier to convert them into crisp value. That is the role of defuzzification. Now just now I have said you one example in fuzzification, that if a crisp value has been there, fuzzifier means it converts into fuzzy sets. So here we gone something like that, large positive, medium positive, small, medium negative, something like that we have converted. So still large positive means it doesn't have any value, but still we have divided the numbers into one particular category, I mean any of the category you can take. Now if I say how to execute the fuzzy logic, so you know there are various processes by which you can execute the fuzzy logic. So this is an algorithm for that. The initialization process is the starting one. What happens is that for any of the expert system which is based on fuzzy logic, we are first defining the linguistic variables. Okay, that will be explained by with the help of example, and using these variables I can construct membership function. Membership function is actually a graph, okay, which will give you some value. I mean the fuzzy set will be there, so that value will be mapped to that graph based on what a membership based on the range from 0 to 1. So anyhow that also we'll see now, and also based on this membership function we need to construct the rule base. Rule base, just now I said fuzzy rules. So fuzzy rules is something like if then, so what we are using, if x and y then z rules. Okay, something like fuzzy logic rules has to be adopted. So all of this process comes under initialization process. Now the next thing is about fuzzification. Fuzzification is how I just said you that fuzzification is something you are taking the crisp input data into fuzzy value. That is the second process you can make in that sense. So fuzzification. Then after that, that inference engine is there, right? So in the inference engine, inferencing process performs. So what this inferencing process will perform, it evaluates the rules. So whatever the rules which we have taken in fuzzy rules, so that rules will be evaluated, okay, in the rule base. And you need to come, you know, there are different actions you may have. For different clause, different actions has to be performed by a washing machine, right? For example, if I am taking washing machine as an example, then different time slot has to be taken. So all of these are what the actions. So we need to combine all of those actions. So that's why here we combine the results of each rule, and that output data which I get, that one I need to convert into non-fuzzy values, which is crisp values, by a process called defuzzification. Same thing is there, but this is how something in an algorithm. Now again I am using one example here, which is air conditioner system, okay, which is actually controlled by fuzzy logic system. FLS stands for fuzzy logic system. Now how an AC works? For example, if an AC is there, what happens, uh, you know, there is a room temperature, okay. So the room temperature, it takes the input from room temperature, that what is the current room temperature is, and also what can be the target temperature. What can be the target temperature? That means how much the temperature has to be set for the given AC at the particular place. So for that, you know, what happens is that when you are setting the target temperature, the target something, if I want to decrease the temperature, then I should use the command cool. And if I want to increase the temperature, I should use the command heat. But if I find that the room is already in a stable temperature and no need of changing the temperature of the room, so I can use simply a command called no change. Okay. So in that sense, what happens, this air conditioner works here. So this fuzzy logic system will perform all of these things. So what it will do is, it will take the input from the room temperature, and based on the rules what has been specified by that fuzzy logic, based on that rules it will set the particular temperature target. That only I said you, right, the target has to be set, I mean the action has to be performed. Action is something, you need to increase the temperature, you need to decrease the temperature, there is no need of changing the temperature. So that is something called as an action. So here if I say, so the same thing again here. So system, the fuzzy logic system actually adjusts the temperature of the room according to the current temperature of the room. Okay. So based on the current temperature of the room only, that this fuzzy logic system will adjust accordingly. So the fuzzy engine actually what happens periodically, it's not something that once the AC gets started and if you are using the room temperature it will be for 2-3 hours. No, periodically it compares the room temperature with the target temperature. I mean currently what is the target temperature of the AC, and also it compares with the room temperature. And if based on that, if they find that both are equal, then it's well and good. But if they are not, then there is need to change the command. If there is a possibility that you need to either heat the room or cool the room, based on that the decision will be taken periodically, not only once, periodically it will be taken. So that is the role of fuzzy logic system here. Now we need to see, the first thing is what I said, you need to define the linguistic variables. What input variables you can use. For example, if I am using temperature, so you can have input variables, output variables. So for example, for room temperature what happens, cold, warm, hot is there, are linguistic terms. If I am using specifically, if I am giving more number of variables such as the temperature can be too cold, this is cold, warm, hot, too hot. So these are what the temperatures, these are the variables. So based on this variable, so what we have did, now this is something which we have created a fuzzy set of the variables. So something like that we created, and every member of this set is a linguistic term. And sometimes all of this, too cold means it covers some temperature value, cold it covers some temperature value, warm, hot, something like that it covers. Okay, so based on that we need to set here the first process. The second process is that we need to construct a membership function. Okay, so for membership function construction, what we have to do is that the temperature mostly it can be from 0 degree to 40 degree. Membership function is actually a graph. Okay, so here it forms, this is your triangles are being formed, right? So this is triangles are being formed and the triangles are coinciding. So this is triangular membership function because it forms a triangle here. Okay, so this is one of the type of membership function which is triangular in nature. So now you just understand this. What happened in x-axis, what we are taking input temperatures. Input temperature, something we have taken 0 degree, 10 degree, and we have taken an interval of 10 degrees. So 0 to 10 we have taken one range, 10 to 20 we have taken one range, 20 to 30 we have taken one range, 30 to 40 degree we have taken one range. And this LP indicates for large positive, MP indicates for medium positive, and S indicates for small, and Mn indicates for medium negative, and N indicates for negative. Negative in the sense it won't say that it is in negative temperature, but it's something like there is a cutoff. This 20 degree is something a cutoff, that more than 20 degree is the temperature is cool, I mean it is getting cool, not completely cool, and less than 20 means it is getting in, more than 20 degree means it is getting hot, okay, and less than 20 degree means it is getting cool, so on. And at the end what happens at 0 degree, what happens completely, it is negative, so that's why it is 1. And what are these member functions? The member function stands in value between 0 to 1. 1 means it is high level, that means at 0 degree it is too cold, right, it is too cold. And here what happens, medium negative is something like you can have cold, so this cold value is at 1 at 10 degree. And at the same time if I take S here, this is small, so this is small, something like we have taken, right, some variables here, we have taken warm, okay, we have taken this as warm. And next is what, hot is there and too hot is there, so you can use 30 degree, this is 30 degree, so you can take as hot, and this is too hot, okay. So in that sense you can take the value. So 1 means it is having, that means it is completely at that level. So what happens if you observe here from 0 to 10 at 0 degree, the N value exactly it is not coinciding, but at -1 -2 something like that. So what happens at this point, if you go this line, it is decreasing, the negativity is decreasing, that means too cold is decreasing by 10, okay. So this is the region. So if I take this region, what is this region? This region belongs to 0 to 10 degree, this region belongs to 10 to 20 degree, this region belongs to 20 to 30 degree, and this region belongs to 30 to 40 degree. So if a temperature is there, okay, if a temperature is there at 25 degree, let us assume here at 25 degree, so you cannot say directly that it is in small or it is in, what is that, medium positive, because exactly at 30 degree only medium positive, but this is how overlapping. But one thing what you can say is that at 25 degree, this value is at 25 degree, so you can say that what is the value you are getting, 0.5. So you can say that at 25 degree it is small with a degree of 0.5, it is small with a degree of 0.5, okay. Also you can say that it is, MP indicates for what, medium positive, that means as I said, what is this, this is what I have taken now, hot and too hot. So if I assume this as hot and this as too hot, and here I assume them as warm, okay. So here what you can say that 25 degree means it is warm to the degree of 0.5, to the degree of 5. Why? Because you are taking 0.5, right? So you can say that 25 degrees centigrade, if I am taking this, so it is what, warm to the degree of 0.5, or you can say to the degree of 5 only, because 0.5. Similarly, if I take 25 degree, what I can say is that it is hot, because it is, this line is also coinciding at 25 degree, right? So at hot it is at 0 to the degree of 0. So something, this temperature you can consider for European countries, okay, not Asian countries, you can consider for European countries. In that sense it best suited for this graph. So here hot is there, so you can say that this 25 degree is hot to the degree of 0.5. So in that sense you can have 25 degree in both the aspects, okay. So based on that we need to consider here, but here at this point it is exactly 0.5. But what if I take 22 degree? What if I take 22 degree? 22 degree means here what happens? Here it will be 0.5. That means for 22 degree it is warm to the degree of 8, because here it is 0.8. It is 0.8 something, and here at the same time if I consider this, so here it will be right, this line, and it is hot to the degree of 0.2. When if I take 22 degree, so now you can perform max or minimum. Okay, if I am performing max means I need to take the highest value, if I am performing minimum means I have to take 0.2 value. That operations also we have seen right previously. These operations, intersection means minimum and union means max operation. So in that sense the values has to be performed here. So that just was an example here to understand that how the things has to be formulated. I mean, if these things will come, so that is why this graphs, this membership functions will be helpful in that sense. Okay, so this is just an example. So now the next thing is about knowledge based rules. So here what the linguistic variables we have taken too cold, cold, warm, hot and too hot, right? So here the room temperature we have taken, and here the room temperature and we have taken, and here we have taken what, the targets. Okay, so now what we have to perform, these are the actions. What are the actions? For example, if the room temperature is too cold and if the target is also too cold, then there is no need to change, so no change will happen. And if the room temperature is too cold and if the target is cold, that means you need to increase the temperature, right? So for that we need to perform action as heat. And if the room temperature is too cold and the target is warm, again you need to heat means you need to increase the temperature. And if the room temperature is too cold and if the target is hot, then again still you need to increase the temperature by performing the action heat. And if it's the too cold room temperature and if you want to take the target as too hot, then you are increasing the temperature as heat. Similarly, what happens is that if I go with hot, let us assume if I am taking hot here, if the room temperature is hot and if I want to make too cold, then I need to perform an action called cool. Similarly, if the room temperature is hot and if I want to the target is cold, then I am using cool. And when the room temperature is hot and if the target is also hot, then there is no change. Here also if the room temperature is too hot and the target is too hot, then there is no change. So that's why there are three actions are being performed. What are this? Heat, cool and no change. So that actions we need to frame the rules. So here we are going to frame the rules. Okay, for this AC only, what we have derived the three rules. What is that? First rule, if you observe, if the temperature is cold or too cold, I mean too cold or too cold, and the target is warm, then you need to increase the temperature because the target is warm. So then the command is what? Heat. And if the temperature is hot or too hot and the target is warm, okay, that means what happens is that the target is actually it should be here cool, not warm. Okay, why? Because if the temperature is hot, or too hot, and if the target is cool, you need to decrease the temperature, right? So the cool will be there. And if the temperature is warm and the target is also warm, then there will be no change. So something like this, the rules has to be formed. So these are the rules that has to be taken now. So these are the rules, based on that actions will be performed here. Now finally what we are doing is defuzzification process. Just now I said you that defuzzification process, I said you what is that? We are taking the output fuzzy values and we need to convert into crisp data. So that is how you need to get by membership functions, that output variables. So that defuzzification process is actually not the part of your mathematical fuzzy logics. So that's why we are not considering them in detail, but just we are seeing what the strategies that are possibly, and mostly these are the strategies here I mean, how can you perform defuzzification is you by performing center of gravity for singleton and finding the average mean and finding the most maximum, rightmost maximum. See, these are the methods by which you can perform defuzzification process. Defuzzification means you are making the converting the fuzzy output set into crisp data is your defuzzification process. Now going to the again membership function, as I already said you what is membership function here, right? In x axis we have taken temperature and y axis we have taken a value from between 0 to 1. So the same thing again here, membership function I am discussing. So what is this membership function is something like whatever the linguistic term we have taken. Linguistic term means here we have taken like n, mn, s, mp, lp. Okay, you can make them as hot, too hot, warm, cool, too cool. So like that you can convert them. Okay, so that linguistic terms are there, so we need to quantify those linguistic terms. How we are quantifying this linguistic term? We are quantifying that the value, if it is there in between n and m, so that has the range between 0 to 10. And if a value has between mn and to s, the value is in between 10 to 20. So we are quantifying the values by taking the range of the values. Okay, so that is the process here. Although this membership function is is a set A on the universe of discourse. That means universe of this x axis is there, right? So here it contains as you know it is a graph. So x axis contain which we have taken temperature, right? 10 degrees, 0 degree, 10, 20, like that we have taken already, we have seen, right? So that is represents as universe of discourse. That means on what the data is to the membership has to be performed. And this is the degree of membership 0 to 1. Just now I have even explained you this example, right? So if it is 22 degree, that means it is hot to the degree of 2, to the degree level of 2, because 0.2 means to the degree of 2, and it is warm to the degree of 0.8. So in that sense you can get the things. So this is how the degree of membership, and that will be present between zeros and ones, because the fuzzy set are actually present in between zeros and ones. So we are taking that y axis here. Again here one example is there. Same thing, like we have taken a voltage value. Okay, so the input voltage is there. So that input voltage we are is actually from minus 10 to plus 10, but we are dividing into a group of values, group of sets. Same thing here, large positive, medium positive, small, and this is what medium negative, and this is large negative. Ln refers for large negative, medium negative, and this is small, and this is what medium positive, and this is large positive. So now that's why you can take plus 5 to plus 10, 0 to plus 5, 0 to minus 5 is in between medium negative and small, and minus 5 to minus 10 is in between large negative to medium negative. Okay, so in that this is also a triangular, same as like as the previous one. Okay, so this is a membership function, but not only this triangular membership functions are there. There are various types of membership functions are there. So as I said you, that is triangular membership function. So here this is a triangular function membership function. So how these values are being taken is how you need to calculate this values means the ranges. Okay, so here if the ranges is there, okay, this is you can consider them as here 10, and this is how 50, and this is 90, and this is how the value of x here. So how you need to calculate is that initially if you take x is less than a means 0. So here the value, if any value is less than a, so 0 is less than, so you are taking this part 0 to 10. Okay, 0 to 10, this is the first value. Okay, triangular membership function. So here what are the sets values we have taken? A, B, C, and upon x we are performing here. So this x is the value we take in here. Now how we need to calculate this, the range between A to B? You need to subtract this value x minus a divided by b minus a. How you have to perform? x minus a divided by b minus a. In that sense you can get the range of this one from 10 to 50. Okay, that means here what is a here? A is 10 and b is 50. Okay, so in that sense. Similarly from b to c means here 50 to 90 here. So how we are assuming that same thing here, what we have taken here as it is at from this side, right side, so you have to start from this c minus x by c minus b. Okay, so we will give you the range. So this is how the triangular form, and this is 1. So in that sense this triangular membership will be provided. So these are the what? The fuzzy sets. What are these? Are the fuzzy sets. So these 4 fuzzy sets are there. So we have taken these 4 fuzzy sets in one triangular representation. 4 values in a single fuzzy set. Okay. Similarly, we have a trapezoidal membership. So this trapezoidal is similar with the triangular, but one thing is there here. For some value, you will have value from here to here, from B to C. If you observe that it is value is 1. Okay, that means this is something like person, age person. Okay, so what is this? You can consider them as age here. So persons who are from 25 to 45, you can consider them as young age, young peoples. Here this value, and here A to B. Okay, you can consider other values. So here what are the values here? 0 to 10, 10 to 25, 25 to 45, and 45 to what is this? You can consider them as the last value, till last value you are considering here. So that's why here 4 sets are there, and here 5 are there. Why it is 5? 5 in the sense, for example, let first is 0. So 0 means exactly 0. This is exactly 0. So here this one value, okay, one value. Then this is A to B. So here 0 means here we are taking from here to here, it is 0. Then from A to B is the second. Okay, then B to C is 1. So here it is B to C. If you observe B to C, you will find as 1. And C to D, same formula how we have did for triangular, the same way for formula has to be implemented. C to D, and finally D is less than X. So here to here you can consider, from here to till here. Okay, so 5 are there here, 1, 2, 3, 4, 5. So trapezoidal means it will be in this form. Okay, triangular means a sharp point will come. That's the difference. How you are getting this as slant? Because the value from here to here it is 1. Okay, it is 1 or any value, but it is static here. So this is trapezoidal, this is triangular. So this membership, based on the values, the particular membership function will be get selected. Similarly, you have Gaussian membership function. In this, what you have to perform is that there are 2 values only. What is this? A and B. And if I want to perform, if I want to draw the graph of this, so I have to know the value of A and B, and this A and B value will be taken and it will be implemented here in this formula. Okay, by getting this e to the power of this, you will get a value, and this value, okay, will be considered till here. So here, as I said 0.22, so you need to consider that value and you need to draw this graph. Okay, 0.22. So 0.22 is here, 0.78 is here. So based on that, you can draw this value and you can have the values here. Okay, and slant curve will be there. and based on this calculation you will get this value and you can draw this membership function. So in this way, not only this, there are various types of membership functions are there, but largely we may use this one. Mostly what we are using is triangular membership functions. Okay. So this is regarding membership function, and finally the next thing is about applications of fuzzy logic. So if you say applications of fuzzy logic, so in fuzzy logic there are various applications that are being used, like it will be used in businesses, okay, I mean to decide the particular strategy to handle such kind of case scenarios, you can use them fuzzy logic, okay, for decision making support system, okay, as something like a software that has to be used in order to select a particular decision has to be adopted. So that will be used in this way, and also it will be used in automotive systems such as traffic and traffic signals. Also you can have fuzzy sets, and automatic transmission or whatever the automotive systems are there, at that time also you can use this one, okay, and it will be used in defense, okay, defense it will be used mostly especially in underwater target recognition, and the next thing is about thermal infrared images, okay, to get this kind of level we are using this fuzzy logic, and also it will be used in pattern recognition and classification, and pattern recognition in any kind of recognition is something like here we are using handwriting recognition, okay, based on what and also it used for fuzzy images. So mostly it will be used in most of the parts, and in securities as also it will used, and it will used in home made appliances such as microwave oven is there, okay. What everyone knows, right, what how this process performs here. So see, fuzzy logic means something we need to reset the values, the machine will decides, machine will set based on the sensors, based on the signals. So signals can be received through sensors even, so that sensors are responsible for giving the input to that machine, and based on that input the particular value has to be selected to perform a particular action. And also it will be used in expert system, as I already said you, more of the expert systems are there in the initial part of this unit. So that also it will used in finance, okay. Also it will used in the industries are where for controlling the pH value, okay, the pH value should be in controlled one. So based on that it will select, and also distillation process, because mostly this process will performs in all of this kind of industries, and for even in manufacturing as well. I mean manufacturing for any kind of things, I mean the products should be optimized. So the product can be optimized if you automate the process, if you automate the production by giving more efficiency to that, something such as like here in dairy products as well. And also it will be used in vacuum cleaners and washing machines. I said you an example. It also used in heaters. All these are in homemade appliances, ACs and humidifiers, okay. So all these are what the applications of fuzzy logics, okay. So this is regarding fuzzy logic. So what you people need to understand is that main thing is about the architecture of fuzzy logic is important in this one, and example has to be adopted, and we need to see about the membership function. So this is example will give you a clarity that how the things will performed here, okay. So this is regarding the concept on fuzzy logic. So with this I conclude this class. Thank you.